Hi boys and girls, today we're going to be doing lesson 3, which is volume of pyramids and cones. So taking a look at the do now, it says a right circular cylinder, I'm going to highlight that, has a height of 12 feet and a diameter of 18 feet. They want us to find the volume of the cylinder to the nearest tenth. And they give us this formula for the cylinder. So before we go to the formula, let's just talk about the diagram. They give us a diagram of the cylinder. So they give us a height of 12, so that means how tall it is. So from here all the way down to the bottom, that would be considered the height. That's 12 feet. Then they give us the diameter. Well, the diameter has to do with the circular part, right? The circular base. So this circle up here, the diameter would mean it's going all the way across through the center. So that means from here to here would be 18 feet. Okay, that's really all the information they give us from the directions. So what I'm also going to do on the left side is I'm just going to write out what they told me. So they gave me the height was 12, and they gave me the diameter, so I'm going to put D, was 18. That's all they gave us. So let's look at our formula. It says V equals pi r squared h. So I'm going to rewrite V equals, I'm going to rewrite pi, but now it says r. Well, they didn't give me anything about r, and r is the radius. So what we have to do is we have to take the diameter, this whole thing over here, and we have to cut it in half. So half of 18 would be 9, which would be this section right here. So whenever I write out the diameter, I also write out the radius, just in case I need it. So like in this formula, we didn't need the diameter, we needed the radius. So I got to find it. So exactly what I did on the diagram, I'm just going to write over here. So my radius equals half of the diameter. So it's 18 divided by 2, which is how I got my 9. That's what I want to plug in for r. So pi, then I put 9 in place of r. Make sure you write the squared. And then instead of h, I'm going to put 12 because they told me the height was 12. Now, in the directions, it says to round to the nearest tenth. So whenever it says round to the nearest tenth, I can put everything in the calculator, including the pi. I know sometimes we don't put the pi in, sometimes we do. Whenever it says to round, we want to make sure we put that in. So you're going to go to your calculator. You're going to hit pi. So you're going to hit second, and then the caret key over here underneath clear. That will give you the pi symbol. Then you type in exactly what you see, parentheses 9. Square it, parentheses 12, enter. You get this big long number. So you get V equals 3053.628059. But they want us to round to the nearest tenth. We know that the tenths place is one spot after the decimal, which is the 6. So I'm going to look at the 2 right next to it. If it's 5 or more, I'm going to raise the score. If it's 4 or less, I give it a rest. So this 2 is less than 4, so I keep the 6 the same. So 3053.6. Now, they give us feet, so I want to put feet. And whenever we're talking about volume, we want to do the units cubed. So feet cubed. This would be my final answer for the do now. Looking at the next piece, is identify the figures formed when the triangles are rotated about the provided axis. So they're asking if I take this and I rotate it around this line right here, what's going to end up happening? So if you look at this, it's kind of a model of it, of this one, and I take it and I spin it, I rotate it, I turn it. Okay, so what's happening with this bottom piece, it's going in a circular motion and it's creating a circular base. Okay, so this is coming around and around. So what I'm going to do is I'm going to sketch that on my paper. Oops. So this piece, this bottom piece of the triangle, forms a circle around the bottom. And then this I can draw right here to represent what looks like a cone. Now let's look at the other side, this one. Same thing, if I turn it around, I rotate it, what's happening is this piece up here is forming a circular shape, circular base. So I'm going to do the same thing here. I'm going to draw my circular base. And then if I connect this, again, we have a cone. One's just a little bit wider, the other one's a little bit narrower. So what I want to write here, just for my notes, is I want to put one circular base forms a cone. You've learned in previous lessons about cylinders, or even on the Do Now. A cylinder has two circular bases, the top and the bottom. A cone just has one circular base. All right, example 1. A cone fits inside a cylinder. So I have two things. I have a cone inside a cylinder so that their bases are the same. I'm going to highlight that. And their heights are the same, as shown below. Calculate the volume of the cone. Give an exact answer in terms of pi, which we'll talk about in a minute. So let's look at our diagram. A little tough to see the numbers, so I'm just going to write them a little bigger. This is a 12 on the diagram, and then this is a 5 down here. So I have my cone, which is right here, inside my cylinder. They want me to find the volume of the cone, and they said that the height and the bases are the same. So this height is for the cylinder. It's also for the cone. If I measured the height of the cone, it would be the same exact thing. It would also be 12. They share a base down here at the bottom. So they also have the same base, which means they have the same radius. So I'm just going to label this piece as the radius. All right, let's look at our formula. V equals 1/3 pi r squared h. So my pieces that I have in my diagram and that I need for my formula is r and h. So my r was half of the circle, so it's 5, and my height was how tall it was, so 12. So now if I go to plug in, I have V equals 1/3 pi. Then I have my r, which was 5 right here, plugging that in. And then my height, which was 12. So I know on the Do Now, we took everything and plugged it in the calculator. This question's a little bit different because it doesn't tell us to round. It tells us give an exact answer in terms of pi. What that means is that pi must be in your answer. So pi must be in the answer. So what I'm going to do is I'm going to rewrite this pi over here. It's going to be at the end. So V equals, I'm bringing down my pi, and what I'm going to do is I'm going to type everything else in the calculator. So the 1/3 has to go in the calculator, the 5 squared, and the 12. So, clear that out. You can do this two ways. You can use the alpha y equals, or you can just type in the fraction in parentheses. So 1 divided by 3, put in my fraction in parentheses. I'm skipping the pi because I wrote that down already. 5 squared times my 12. So I get 100. So all I need to do is bring down that 100. So I have V equals 100 pi as my final answer. They don't give me any units like feet or inches. So I can leave it like that, 100 pi, but we should really know that it's always going to be the units cubed. You can always add that as a note. So that would be your final answer for example 1. Next page. All right, example 2. They want us to find, oh, I'm sorry, reading the wrong question. It says the side length of the base of a square-based pyramid is 4 inches. So the side length, I'm going to write that down, length of the base of a square-based pyramid is 4 inches. So the length is 4 inches. So let's look at our diagram. So this is a square-based pyramid. So that means the bottom of the pyramid, or the base of the pyramid, is right here. They're saying that this is a square. And they told us that one side is 4 inches. So if one side is 4 inches, we know a square has all equal sides. So all 4 of them are 4 inches, all 4 sides. Now if I keep reading, it says the height of the pyramid is 15 inches. So I'm talking about the height. It has to make a right angle with the base. It has to be perpendicular to the base. So what I'm going to do for the height, a lot of people make a mistake on this and they think this is the height, when really the height has to come directly down the middle, oops, to the center and form a right angle with the base. So this is really my height, which is 15 inches. And I can write that over here. H equals 15 inches. Now let's look at our formula. They want us to find the volume of the pyramid. So if you look here, they give you the formula for pyramid. So it says V equals 1/3 capital B H. So this capital B you learned in previous lessons. It means the area of the base, or the base area. And they told us in the directions that it was a square base. I'm going to write that down, a square base. So that means we're doing the area of a square for that capital B. So an area of a square is length times width. So I not only need the length over here, but I also need the width of the base. Well, if it's a square base, then all the sides are equal. So if the length is 4, then the width is also 4. Now when I rewrite my formula, what I always do is I rewrite something in place of this capital B. So I'm going to rewrite V equals, keep the 1/3. Now instead of B, or instead of capital B, I should say, I'm going to replace that with length times width. And then I'm going to carry down my H because that was in my original formula. So now I can begin to plug in. V equals 1/3. Well, the length was 4. The width was also 4 because it was a square base. And then the height, they told us in the directions, was 15. I type all of this in the calculator. Once I type it all in, 1/3 times 4 times 4 times 15, I get 80. And my units were inches. So I put inches. Whenever we're talking about volume, it's inches cubed. So this is my final answer for example 2. Taking a look at example 3, part A. They give us this cone right here, and they say determine the radius of the circular base. Okay, so radius we know is R, and it has to do with the circular base. So what I'm going to do is, the only piece that's inside the circular base right here is this. I'm going to label that as radius. Okay, so determine the radius of the circular base of the given cone below using Pythagorean theorem. A squared plus B squared equals C squared. So first thing I'm going to do is I'm going to rewrite that formula. A squared, B squared equals C squared. The most important part of this formula is the letter C. C is always represented by the hypotenuse. We know that the hypotenuse is always across from the right angle. It's always the longest side. So I'm going to label that hypotenuse, and I'm also going to put a C there. So I automatically know that's going in place of my C in my formula. The other two don't really matter. It could be A or B, B or A, doesn't really matter. I'm going to put this one as A, this one as B. I put an X by the radius because that's what they asked us to find. So since I'm using that as my A, instead of A, I'm going to put my X squared plus B is 11 squared equals C, which is the square root of 137 squared. So watch how I'm going to write this. I'm going to write parentheses, square root, 137, close parentheses, and then square it, just like I did with the 11. So I bring down my X squared. I can't do anything with that. 11 squared is 121. And square root of 137 squared. So in your calculator, what you're going to do, type in exactly what you see. Parentheses, square root, 137. Put the arrow to the right, close your parentheses, and then square that whole thing. And what happens is you get what's inside the square root. So it comes out to 137. And now I just finished solving for X. I got to get X alone. I bring over the 121 by subtracting. I get X squared equals 16. I'm just going to write it over here. X squared equals 16. Now still the X is not alone, it's squared. I need to get rid of that squared by doing the opposite, which is square root. Square root of 16 is 4. So my 4 can go up here. And they were looking for the radius, so I really should say the radius equals 4. Now the second part says determine the volume of the cone in terms of pi. We saw that earlier. And determine the volume of the cone. So they gave us the formula already. V equals 1/3 pi. Now I need the R and I need the H. R stands for radius. Well, I just found out what the radius was. In part A, we found out the radius was 4. And the H stands for height. So the height is always making a right angle, forming a right angle with the base. So the height is this one, 11. Let's write that down, height. 11. So now we just plug in. 1/3 pi, I put 4 in place of my R, squared, and then 11 in place of my H. Now because it says in terms of pi, we talked about that earlier, what you're going to do is you're going to carry down the pi into your answer. It must be in your answer. And put everything else in the calculator. So the 1/3 goes in the calculator, the 4 squared, and the 11. The pi just carries down. So once you type that in, 1/3 times 4 squared times 11. You can do this 2 ways. Really depends on your preference, but there we go. You can do parentheses, 1 divided by 3, close parentheses. Leave the pi off, because we already brought that down. 4 squared times 11. You get this big long decimal, which is really ugly to write, and they didn't tell us to round or anything. So what I would do, you can write 58.6 repeating pi, or you can use that alpha y equals function. So you can do alpha y equals. Then you can type in the 1/3. And then the 4 squared and the 11, and it will give it to you in fraction form. So if it's fraction form, it's 176/3. So I'm going to write it that way, 176/3 pi. Or you could do the 58.6 repeating pi. Either one is technically correct. If you did it the first way and you got this as your answer, what you could always do is you can hit math, enter, enter, and it will change it to the fraction right then and there for you. So that's just another option for you. All right, next page. Find the volume of the following rectangular-based pyramid. So we're going to find the volume of the rectangular-based pyramid. So before we had a square-based pyramid, now we have a rectangular-based pyramid. They give us all our information on the diagram. So they give us a 9.5, they give us an 8, and they give us a 9. So in our formula, it says V equals 1/3, that capital B again, which I know means the base area, or the area of the base. Well, the base is a rectangular shape. So rectangular base. Well, if I was finding the area of a rectangle, I would be doing length times width. So I'm going to rewrite this formula, V equals 1/3. Instead of that capital B, I'm going to replace it with this length and width. So I'm going to put parentheses L, parentheses W, and then carry down my H for my formula. So I now need 3 pieces, L, W, H. Well, on my diagram, I have all 3 pieces. I have the length, I have the width, and then the height is always, remember, forming a right angle with the base. So the length, I want to write 9.5, the width 8, the height 9. Now I just plug in. B equals 1/3. The length we said was 9.5, the width we said was 8, the height we said was 9. Type it all in the calculator. You should come up with 228. My units was centimeters. So I put centimeters, and because it's volume, it's always centimeters cubed. That would be my final answer for example 4. And example 5. Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches. I'm going to write that down right away. H is 8 inches. Height is 8 inches. And a diameter of 3 inches. So I'm going to put D for diameter equals 3 inches. To the nearest cubic inch, what will be the total volume of 100 candles? Okay, so we have our diagram here, and they give us some information. They give us a height, and they give us a diameter. Well, the height always goes straight down the middle and forms a right angle with the base. So my height, again, goes right down the middle. That would be my 8 inches. Now, the only other information they gave me was a diameter, which was 3 inches. Remember, the diameter is the whole thing. So from here to here would be 3 inches. Oops. So let's look at our formula again. It says V equals 1/3 pi, but now it says R. I didn't figure out R yet. I only figured out H and D. To figure out R, just like we did earlier, the R is always the diameter cut in half. So it's 3 divided by 2, which gives me 1.5. So this half would have been 1.5. So that's what gets plugged in for my R. And then my H, we know, was 8. They gave that to us. So I put that in my calculator. 1/3 pi 1.5 squared times 8. I get this big long number. 18.849555592. Now a lot of us look here and we say, oh, it says the nearest cubic inch, so I have to round. We are not done with this problem yet. What we just found was a volume of a cone. So we really only found the volume of one cone. So this represents the volume of one cone. But Walter, from the problem, wants to make 100 cones, and we need to figure out what will be the total volume of, 100 candles, right, which are in the shape of a cone. So the volume of 100 candles, what we need to do is take our answer and we need to multiply it by 100, because again, this is only the volume of one cone or one candle. We need 100 candles. So you take that number, which should be in your calculator still, and you multiply it by 100. When you multiply it by 100, you get 1884.9555592. So the decimal moved over twice to the right. Now we can round to the nearest cubic inch. The nearest cubic inch is like the nearest whole number. So I'm looking at this 4 right here. Well, this 9 is 5 or more. We raise the score. So this becomes 1,885 inches cubed. That's the volume of 100 candles. Okay. Your job is to do the independent practice problems. So just some hints here. Don't forget this capital B means the area of the base. In terms of pi, means pi needs to be in your answer. Down here, they give you some information. They give you the diameter. They give you the height. Just be careful. There's an R in here. So look back on your notes what you have to do to get the R. Okay? Good luck, and I'll see you on the next video.